April 14, 1912. On its maiden voyage to America from Southampton, England, the RMS Titanic struck an iceberg at 11:40 p.m. in the middle of the Atlantic Ocean. The vessel took on an alarming amount of water, causing the ship to fully submerge at 2:20 a.m. on April 15th. Out of 2,224 passengers, 1,503 perished. Today, the ship lies 12,415 feet, or 2.4 miles at the bottom of the Atlantic Ocean. Many artifacts are still visible on the ship, such as dishes, furniture, and even clothes. However, nowhere on the ship is there any remnants of human remains. Oddly enough, human remains are still present at the wreck site of the Great Lakes freighter, the Edmund Fitzgerald, which sunk in 1975 in Lake Superior. Why are human remains present in Lake Superior but not in the Atlantic Ocean? Let's see why. At the moment, you're experiencing 1 atmosphere pressure, or 14.5 pounds per square inch, on Earth's surface. This 14.5 pounds per square inch is atmospheric pressure caused by the force of gravity, pulling down atmospheric gases towards Earth. You don't really notice the force of 1 atmosphere because you've become used to it. Conversely, the Titanic sits 2.4 miles at the bottom of the Atlantic Ocean. The pressure at 2.4 miles is much more than 1 atmosphere pressure. It's 377 atmospheres, or 5,540 pounds per square inch. The pressure is higher at this depth because of hydrostatic pressure from the water in the ocean. Hydrostatic pressure is the pressure exerted by a fluid due to the force of gravity. As you move deeper underwater, the pressure increases because of the increasing weight of fluid exerting downward force from above. In fact, for every 33 meters you travel downward in the ocean, the pressure increases by 14.5 pounds per square inch. This magnitude of pressure does not seem to affect much of the ship, such as steel or iron, and even some solid glass materials, due to their strong compressive strength. However, one thing that definitely cannot withstand this pressure is the human body. If you're thinking of intense pressure and bone, and you're starting to cringe, you're on the right track. As the trapped bodies of the passengers sank with the ship lower and lower into the depths of the ocean, the high pressure began to affect the bodies. All the gaseous and hollow cavities would have been completely crushed and dissolved in the water. This is due to the pressure difference in the cavity, which is much lower than the pressure outside the body. Naturally, pressure differentials become equalized, and as a result, the cavity is shattered. Such gaseous and hollow portions of the body would be the abdominal, thoracic, and cranial cavities, not to mention any hollow or gaseous organs such as the lungs, stomach, and intestines. Weaker, thin bones would also break under the high pressure as well, such as fingers, toes, and possibly ribs. The depth the Fitzgerald sunk was only 540 feet, which is 33 atmospheres, or 242 pounds per square inch. Not quite enough to shatter body cavities. In fact, the world record for deep-sea diving is much deeper than the depth of the Fitzgerald. In 2014, Egyptian scuba diver Ahmed Gabir swam to the depth of 1,090 feet, with a pressure of 485 pounds per square inch. Even at this depth, human bodies are still unaffected by the pressure. Now back to the Titanic. Though the cavities and some weak bones were destroyed, more thick and solid bones would not have shattered even under the intense pressure. For example, the human femur, the strongest bone in the body, can withstand as high as 23,000 pounds per square inch before shattering. So this sort of begs the question, why aren't there any human remains of femurs present at the Titanic site? The reason for this is twofold. Though the pressure does not instantly shatter the thicker bones, over time, with the pressure being applied constantly, it certainly fatigues the bone structure, making it weaker and brittle. The second aspect is the composition of the water. The Atlantic Ocean is composed of salt water, which tends to be more reactive in breaking down organic material. With these two conditions, the constant high pressure and exposure to salt water, any remaining organic material would have slowly broken apart and dissolved in the water. Not to mention, any aquatic life would have eaten what pieces of remains were still left. The reason human remains can still be found at the Fitzgerald site is because the water pressure is nowhere near as high. Not to mention the Fitzgerald sunk in Lake Superior, which is fresh water, not salt water. In fact, under the low pressure conditions and fresh water, at a depth low enough to sequester atmospheric oxygen from the environment, Lake Superior actually preserves the dead bodies. This is why the saying goes, Lake Superior never gives up her dead.